Hey, welcome back to ClearSpot. This utility manages 1,200 megawatts of solar generation with fewer people than most companies use for 100 megawatts. Their secret? AI grid agents that orchestrate gigawatt-scale complexity like a symphony conductor, optimizing every electron and predicting grid needs minutes before they occur. While most utilities struggle with renewable integration, these companies are turning solar variability into their competitive advantage. What you're about to see will change how you think about utility-scale solar management forever. In the next 7 minutes, you'll discover why traditional utility operations break down at gigawatt scale. The 4 AI grid agents that transform utilities into renewable energy leaders, how AI agents turn solar variability from problem into profit center, and the exact strategy utilities use to achieve 25% operational cost reductions. Utilities face an unprecedented challenge, managing renewable energy at scales that dwarf anything in human history. Complexity explosion. Modern utilities manage 500 to 2,000 megawatts of solar across multiple installations. Each 100 megawatt solar farm has over 300,000 individual components requiring coordination. Grid integration demands millisecond response times across vast geographic areas. Renewable portfolio standards require 50 to 80% clean energy by 2030. Operational impossibilities? Human operators can actively monitor maybe 50 systems simultaneously. Solar production varies by 30 to 70% based on weather conditions. Grid stability requires perfect balance between generation and demand. Traditional control systems were designed for predictable fossil fuel generation. Strategic imperatives, competitive markets demanding lowest cost energy, regulatory requirements for grid reliability and environmental compliance, customer expectations for 99.99% service reliability, and infrastructure investment decisions affecting decades of operations. The utilities solving this aren't hiring more grid operators. They're deploying AI grid agents that think and react faster than any human team possible. AI grid agents function like specialized digital grid operators, each managing different aspects of utility-scale operations. The production forecasting agent predicts solar production with remarkable accuracy using weather data, satellite imagery, and machine learning models. Its forecasting capabilities include 72-hour production forecasting with 95% accuracy, real-time cloud tracking and production adjustment, seasonal pattern analysis for long-term planning, integration with weather services and climate models, and automated production scheduling for optimal grid support. Then, there's the grid optimization agent. This agent manages real-time grid operations, balancing supply and demand while maintaining stability across vast transmission networks. Operations management features include millisecond response to grid frequency variations, voltage regulation coordination across multiple installations, power factor optimization for transmission efficiency, load following and regulation services providing ancillary revenue, and emergency response protocols for grid stability events. Next up, the market intelligence agent. This agent optimizes participation in energy markets, maximizing revenue from solar generation and ancillary services. Market optimization covers real-time energy market bidding and optimization, capacity market participation and revenue maximization, renewable energy credit trading and management, demand response coordination and customer engagement, as well as long-term contract optimization and risk management. Finally, the asset intelligence agent manages the long-term health and performance of utility-scale solar portfolios across decades-long life cycles. Asset management includes component-level degradation tracking across the entire portfolio, predictive maintenance scheduling minimizing downtime, replacement planning and capital expenditure optimization, performance benchmarking and continuous improvement, and warranty management plus vendor relationship optimization. Here's how AI grid agents revolutionize utility operations. So, with predictive grid management, instead of just reacting to grid conditions, AI agents actually predict and prepare for changes minutes or even hours in advance. The predictive advantages are, honestly, pretty remarkable. There's up to a 90% reduction in grid stability incidents through proactive management, a 25% improvement in renewable integration without needing infrastructure upgrades, and a 60% faster response to emergency grid conditions. Now, moving on to autonomous revenue optimization. AI agents continuously optimize energy market participation, finding revenue opportunities that human operators might miss. The revenue enhancement potential includes a 15 to 30% increase in energy market revenue, through optimal bidding, a 40% improvement in ancillary services revenue capture, and a 20% reduction in transmission costs through intelligent coordination. When it comes to intelligent asset orchestration, AI agents can coordinate thousands of individual solar installations as if they were a single massive power plant. The coordination benefits are just staggering: a 95% reduction in operational complexity despite the massive scale, a 50% improvement in grid services capability, and an 80% reduction in manual coordination and oversight requirements. Finally, let's talk about predictive infrastructure planning. AI agents analyze long-term trends and optimize infrastructure investments for maximum return. The planning optimization includes a 70% improvement in capital allocation efficiency, a 25% reduction in infrastructure upgrade requirements, and a 90% accuracy in long-term capacity planning. Successful utility AI implementation really follows the strategic approach. First, there's Phase 1, infrastructure assessment, which usually takes about 1 to 2 months. Here, you evaluate existing SCADA systems, market integration capabilities, and data infrastructure. Interestingly, most utilities actually need minimal upgrades for AI integration. Then, Phase 2 is the pilot installation, typically in months 3 to 4. You deploy AI agents on a single large installation, say 100 to 200 megawatts, to validate capabilities and demonstrate ROI without risking grid stability. Next, Phase 3 is market integration, which happens around months 4 to 6. That's when you integrate AI agents with energy market systems and begin automated market participation under human supervision. Phase 4 is portfolio expansion, usually between months 6 and 12. You gradually expand AI management across the entire solar portfolio while adding advanced capabilities like predictive maintenance. Finally, Phase 5 is advanced optimization, starting in year 2 and beyond. Here, you deploy full autonomous capabilities, including infrastructure planning, advanced market strategies, and grid services optimization. Now, some critical success factors: regulatory compliance and utility commission approval, integration with existing energy management systems, staff training on AI supervision and optimization, cybersecurity enhancement for AI system protection, and of course, a gradual transition that maintains grid reliability throughout. Utilities deploying AI grid agents gain several strategic advantages. First, there's operational excellence, with a 25% reduction in operating costs while actually improving reliability and service quality. Then, there's market leadership, the ability to offer competitive energy prices while maintaining profitability through intelligent optimization. On top of that, there's a regulatory advantage, with superior compliance capabilities and environmental performance that support favorable regulatory treatment. AI also provides an innovation platform, supporting future smart grid developments and customer services. And don't forget about risk mitigation, with predictive capabilities and autonomous responses reducing both operational and financial risks. The result? AI-enhanced utilities achieve lower costs, higher reliability, and better environmental performance simultaneously, the trifecta of utility success. The utility industry is transforming rapidly. AI-enhanced utilities are achieving operational performance that traditional approaches simply can't match. Early adopters are going to dominate the next decade of renewable energy. If your utility manages 100 megawatts or more of solar capacity, you really need to understand exactly how AI grid agents can optimize your specific operations. So here's what you should do. Take strategic action today. Step 1. Access our free utility AI assessment through the link below. It evaluates your current grid operations and identifies the highest impact opportunities for AI agents. Step 2. Schedule a free strategic consultation with ClearSpot AI S utility specialists. We'll analyze your specific grid requirements and demonstrate potential operational improvements. Step 3. Subscribe for our final video in this series, the complete implementation roadmap showing exactly how to deploy AI agents for maximum ROI. The future of utility operations is autonomous, intelligent, and dramatically more efficient. Your competitors and regulatory authorities are watching closely. Don't let others gain the strategic advantage. Like, share, and subscribe for more solar insights. ClearSpot. Smart device. Smarter decisions.